So up on top here, I'm just asking you to do some conversions. Rods into inches is a little bit of a tricky conversion. Make it 4 rods over 1. And our conversion factor here, rods are going to go on bottom, but we don't have a direct conversion from rods to inches, and I don't expect us to find one. So what do we have a direct conversion from rods into? Yeah, we can go feet or yards, but it makes more sense to go feet because that's closer to inches, right? Which one's larger, feet or rods? A rod is larger, so we put the 1 with a rod. How many feet are in a rod? 16.5. So I cancel, the rods are gone. Now I could multiply this out and get feet and then convert to inches, or I can just put the next conversion factor right here. Put feet on bottom to get rid of them, going into inches. The foot is still bigger, so it's 1 foot equals 12 inches. So now the feet are gone, and now I'm in inches. So on bottom, I just have 1, 1, and 1. So it's just going to be 1 on bottom. On top, 4 times 16.5 times 12. $792 inches. How many of you had 792 inches? 1?
I didn't do that one.
Didn't do that one?
I just did the final perimeter.
Okay.
Yeah.
For millimeters into meters, on the chart, from millimeters to meters is 3 spots to the left. So our decimal point has to go 3 spots to the left. That becomes 0.82 meters. Now the part you've all been waiting for. If we cut that across there, we know this piece would have to be 20 to match the top. Since this is a radius of 4, that makes it a diameter of 8, which makes this 8, which means we can find this. Yes, 17 squared minus 8 squared will give us, I'll call that A squared. So 17 squared is 289. 8 squared is 64. We subtract to get 225. Is A squared. We square root that. Get that this A has to be 15. So that means the base down here has to be 35. So to find the area, we have 2 pieces. We have the half circle and we have the trapezoid. The trapezoid, its area is going to be 20 plus 35 divided by 2. Average of the bases times the height of 8, which is going to give us what? 220 inches squared. And then second, we got the half circle there. That is going to be pi times 4 squared or 8 squared? What do we use for the area? Radius or diameter? Radius, so it'll be 4 squared. Divided by 2 though, because it's only half circle. So pi times 4 squared is 50.24, divided by 2 is 25.12 inches squared. Adding those together, we get 245.12 inches squared. So that is our area. To find perimeter, we need to find the distance around that half circle first. That circumference is going to be pi times diameter, pi times 8, divided by 2, because it is only half circle, which is 12.56 inches. To that, we're going to add 20, 17, and 35. .56 inches is the perimeter. How many of you had both of those right? Anybody have any questions on where I got them? Okay. So, I gave you guys a packet when you left here yesterday. Realized it was formed after you left that I've already given you that packet, so no extra charge for having a second copy. You got one you can share with family and friends. You know, you have people over this weekend, you can hand out an extra packet for them. That's when you pop the popcorn and put the math videos on the TV anyway. Like I said, I get half of the gate if you charge admission. So anyway, our next step is we want to talk more about circles. And I've showed you, we've looked at the formula for circles. The circumference of a circle, which is the perimeter of the circle, is pi times the diameter. And remember, the diameter is a chord. A chord is just any line segment that connects 2 points on the circle. Well, diameter is a chord that goes through the center. That's our diameter. Area, then, is pi times radius squared. And of course, the radius is just distance from center out to the edge, or half of the diameter. So the first thing I want to look at today is when we don't have a whole circle. Now, we've done half circles, quarter circles, stuff like that. We've done things like this, where I want to find the area of that. This, by the way, is called a sector. It's a pi wedge of a circle. It's the portion of a circle that is separated by any two radii. So this is a radius here, and this is a radius here. It's the area of the circle in between those two radii. This has a radius of 5 millimeters. If I want to find the area of that little symbol there is the area for the symbol for a sector. The area of that sector we found was pi times 5 squared divided by 4 because it's a quarter circle. Or we could have done times 1/4 because it's 1/4 of a circle. The question is, where does that fraction come from? Well, we know it's a fourth of a circle because it's 90 degrees. A full circle is 360 degrees. That's 93/60ths. So technically what we're doing there is we are taking pi times radius squared. We're taking the area of the whole circle and we're multiplying by that fraction of a circle, that angle, over 360. So the definition of the area of a sector is the area of the full circle times this symbol here is the symbol for an angle. It's the Greek symbol theta. It's just an O with a line through it like that. So it's the area of the whole circle times that angle divided by 360. So if we have a sector that is not 90 degrees or 180 degrees, not a quarter circle or a half circle, let's say we have a sector that is 60 degrees. And let's say this here is 10 millimeters. I would start by finding the area of the whole circle, which is pi times 10 squared, otherwise known as 314 millimeters squared. That part look familiar? So that's the area if this were a whole circle. Now the area of a sector is found by taking the area of that whole circle, 314 millimeters squared, times the central angle over 360. What's the central angle? 60 degrees, right? Over 360 degrees. So 314 millimeters squared times 60 divided by 360 is 52.33 millimeters squared. That's the area of that sector. Make sense? Find the area of that sector in your notes. So our first step is to find the area of the whole circle, which will be pi times 8 squared, 200.96. You got it. Then what?
1.96 times 1.over.
Perfect. Take the area of the whole circle, 200.96 times 120 degrees out of 360 degrees, which is going to give us 66.99 inches squared about. How many of you got 66.99? How many have no idea where I got 66.99? Okay, well, so that's a sector. That's the area. Next, we want to look at, if I have a circle here with a diameter of 12 millimeters, we found its circumference was simply pi times 12. Well, pi times 12, or 3.14 times 12, gives us 37.68 millimeters. If it was a quarter circle and I just wanted to find the length around here, I would have divided by 4, or again, times 1/4, which is 93/60th, because it's a 90-degree angle. This piece of the circumference like that is called an arc. And when we're looking at the arc length, or the length of an arc, it is the circumference of the circle times that angle over 360 again. So if I have a circle like this, and I have a 120-degree angle here, and a radius of 8 inches, and I want to know the length of this arc.
What do you call that symbol again?
Theta?
Yeah, but the angle.
That's just an angle. Yeah, that's just this angle. This is theta right here. That angle. So I want to know the length of this arc. Find the arc length. So I'm going to start out by finding the circumference of the whole circle, which is pi times diameter, which would be 16 inches. 50.24 inches is my circumference. So now I find my arc length, AL, by taking that 50.24 times 120 or 360, which is going to give me 16.75 inches approximately. Make sense? So in your notes, so you have a 60-degree angle here, and you have a 5 millimeter radius. Find that arc length for me. So step 1 is to find the area, or the circumference of the whole circle, which is pi times 10 millimeters. You got to remember to double the radius to get the diameter. So that's 31.4 millimeters. So then the arc length is at 31.4 millimeters times 60 degrees over 360 degrees, otherwise known as 5.23 millimeters. How many of you had that? Good deal. Well, we're going to step this one up just a little bit. The 10? I had to double this to get the diameter, because this is the radius. You
I
should,
have a garage number 331 Bonnie.
okay.
I will try to calculate this to know 10.
So this would be 31.4 times 60 divided by 360.
Yeah.
Came out something different? Something must just got punched in wrong. Okay. We're going to look at something like this. Let's say that this is 120 degrees here. This is 8 inches. 8 inches, obviously, they're both radii of a circle. So what I have here is I have a chord on my circle going from here to here. And that chord, if I draw the radius from the center of the circle to one end of the chord, and then I do the other end of the chord, so I draw on those two radii, they form an angle in the center here of 120 degrees. What I want to find is the area of this little sliver out here. This sliver is what's called a segment. To find the area of a segment, I have to find, if we had, something like this, you know how we found the area of this whole thing, then subtracted out the area of that little rectangle, right? Same type of thing here. We've got to find the area of the whole sector, and then subtract out the triangle. So let's start by finding the area of the whole sector. To do that, we need the area of the whole circle, which is pi times 8 squared, 200.96 inches squared. So then the area of the sector, 200.96 inches squared times 120 over 360 is going to be 66.99 inches squared. So that's the area of the whole sector. For the triangle, we don't have any right angles, do we? But we do have all three sides. So we can find the perimeter of the triangle is 8 plus 8 plus 13.8564, otherwise known as 29.8564 inches. Which means that our semi-perimeter is 29.8564 over 2, otherwise known as 14.9282 inches. Now remember, the formula for area is the square root of s times s minus a times s minus b times s minus c, right? Well, a is the 8, b is the other 8, and c is the 13.8564. So we're going to have 14.9282 times 14.9282 minus 8 is 6.9282. I'm just doing the subtraction in my head so we don't have to write it all out. 14.9282 again minus another 8 is still 6.9282. And then 14.9282 minus 13.8564 is 1 point. I'm subtracting wrong. 1.0718. Does that look correct? So now I've got to multiply that out with square root. So second square root, 14.9282 times 6.92. Ah, crap, screwed it up already. 14.9282 times 6.9282. Instead of typing it in twice, I'm just going to hit squared. Times 1.0718. I get an area of 27.71. That's square inches. So what do I have to do? Take my 66.99 square inches from my whole sector, subtract out the 27.71 square inches for that circle, or for that triangle, and I get 39.28 square inches is the area of my segment. Make sense?
Yeah.
Kind of?
Yeah, makes sense.
Not hard, not easy to do, it's just, it makes sense. Okay. Okay then.
So if you would have been able to find the area of that triangle, you could have taken that minus your circumference of the circle, right?
From your, no, from the area of the sector.
Yeah.
This is the area of the sector that we found. Then we had to find the area of the triangle. If it had been a right angle or something.
Would ever be a, yeah,
Yeah, there might be one where it's a 90-degree angle there. It's easy to find the area of the triangle.
that's what I'm saying. So then you take the area of the sector minus the area of the triangle.
Yeah. And that's all this is the area of the triangle. We just had to use Hero's formula to do it. So in this one, still looking for the area of this segment. This is a 60-degree angle in here. Let's say this is 10 inches and 10 inches. Now, if this is a 60-degree angle in here, the whole triangle adds up to 180 degrees. So that means 180 minus 60, there's got to be 120 between the other two angles. A little known rule about triangles is the longest side is always opposite the longest angle. The consequence of that is if two angles are opposite the same sides of the same length, they have to be the same. So what that comes down to is these angles are both 60 degrees. So what's that make the length of this side? 10. So all three of the sides of this triangle are 10 inches. So use that information to find the area of that little sliver, that segment, in your notes. So step 1, find the area of the whole circle. Pi times 10 squared is 314 inches squared. What is step 2?
14 times 60 over 360.
Find the area of that sector, so 314 inches squared times 60 over 360. Which gives us 52.33, correct? That's the area of the sector. Then what?
Find the perimeter.
Perimeter of the triangle.
30.
10 plus 10 plus 10 does equal 30. Semi-perimeter. Hero, Huron, whatever you want to call them, right? So 30 divided by 2 is 15. These are semi-perimeter. Huron's formula, the area, is S of 15 times S minus A times S minus B times S minus C. So I'll punch that in my calculator. Oops, try that again. $43.30?
I got a question.
Yeah.
So if you had if your triangle is a right triangle, I'll let you finish this properly.
Okay. So then we'll subtract that out. We're going to get 9.03 square inches. How many of you got 9.03? Good deal. So if that were a right triangle.
So what I'm saying is, if you use Heron's theory,
It would work.
it'd still be the same. So you can't
Yeah.
get it mixed up.
Yeah, you can't get it. You can always use Huron theory form if you have all two sides.
Okay.
Yeah, but if you have a right triangle there, let's say this is 15 inches and 15 inches. The area of your whole circle is pi times 15 squared. $706.5. Area of your sector, 706.5 times 90 over 360. Or you could just divide by 4. .63 actually probably. 178.63 inches squared. Then the area of the triangle is just simply going to be 15 times 15 and divide by 2. So you just subtract those. So those go really quick. Now, a little known theorem in math governing these chords. Looks like this. If I have two chords that intersect, the chords themselves may or may not be the same length. Yes, sir.
So what was the answer for the last one?
9.03. The chords themselves may or may not be the same length, but the way they divide each other up is predictable. Let's say this chord here is divided into pieces that are 4 inches and 9 inches long. 4 times 9 is 36. The other chord has to be divided into pieces that multiply to 36. So if I tell you that this piece here is 3 inches long, what's this piece have to be? Yeah, 3 times 12 makes 36. So x could be found by doing 4 times 9 divided by 3. And that's true in any circle with two chords that cross. Let's say this is 2, this is 3, this is 9 inches. I want to find x here. I would find x. Which two get multiplied together? The 2 and the 9, because they're in the same chord. So 2 times 9 divided by the 3 is going to give us 6. So that's 6 inches. Where this is most useful is when you're dealing with an arc. I'm trying to think of an example in machining right now, but all I'm coming up with is construction example, so we're going to do a construction example. Let's say you have a 36-inch window. And you want to build an arc, put an arched window above it, like that. The height of that arched window, let's say, is going to be 9 inches. What I want to know is I want to know the radius of the circle that contains that arc. Why do I want to know that radius? Because if I know that radius, I can lay out that arc by finding the center of the circle and putting a nail or whatever there and making a string the length of the radius and just taking my pencil and I can just draw out the arc with that string and the pencil. For applications in machining, it'd be the diameter of your tool would be what you're looking for. So anyway, I'm looking at this here. What I'm going to try, the first thing I'm going to be finding is this length here, which I'm going to call X. So the 9 and X make a chord. It actually makes a diameter going across there. This is a chord here. And since this cuts at a right angle here, it cuts that, the highest point of that arc is going to be at the center of that, right? So it cuts that chord in half. So what's each side of this going to be? Well, the whole thing was 36, right? So each piece is 18. So X here is going to be 18 times 18 divided by 9, or 36 inches. So if X is 36 inches, that tells me my diameter is how much? Yeah, 36 plus 9 is 45 inches. I have this 36 plus the 9. And my radius is just 45 divided by 2, or 22 and a half, 22.5 inches. Now we're running short on time today, so we're going to stop there. We will do more examples of this tomorrow, but it might appear in the packet I'm about to give you. In the packet I'm about to give you, pages 165 through 168, there are questions on circles, chords, sectors, arc lengths, segments, and some of these arches.